Hello everyone, welcome to Sai Tutorials Chamkandi. So in our tutorial, 10th class Kannada medium, English medium, Math, Science, English classes are available in the regular classes as well as in the online classes. So please join us and learn the things. So dear students, today in this session, I am going to discuss about the further concept related to the third chapter of this physics second PUC chapter, that is current electricity. So I have discussed so many things in this chapter. The last concept is remaining here. So that is Wheatstone bridge. Uh, so let us discuss that Wheatstone bridge in detail. Okay, this is very important chapter for 5 marks. This is very important for your 5 marks question. See, this is called as a Wheatstone bridge. So let me clear you in detail. So measurement of resistance. We use the resistance of a wire can be determined using Wheatstone network. So in order to determine the resistance of the wire. So if you want to determine the resistance in the circuit or the wire, which can be determined using the Wheatstone bridge. So what do you mean by Wheatstone bridge and what principle is going to happen in this case and what is the construction for that bridge? So let us discuss in detail. So there are some terms. There are some concept related to this Wheatstone bridge. That is, first thing is principle of Wheatstone bridge. Okay, principle of Wheatstone bridge. See, Wheatstone's bridge consists of an arrangement of four resistances. Okay, so here P, Q, R, and S are the four resistances which can be used to measure one of the resistance in terms of the other resistances. Okay. Here, four resistances are constructed in the Wheatstone bridge, which can be used to measure the one of the resistance, in terms of the other resistance. So the bridge is said to be balanced when deflection in the galvanometer is zero. See, the circuit connection is G. Okay. So let me discuss in detail. This will happen in this P by C. I have told you that four resistors are connected which can be used to measure one of the resistances in terms of the other. So that that resistance in terms of PQRS can be written as P by Q is equal to R by S. Okay. See, in Wheatstone bridge, cell and galvanometer arms are interchangeable. If a bridge is not balanced, the current will flow from D to B. Okay, D to B. These are some concepts related to the Wheatstone bridge. So let me discuss in detail. Wheatstone bridge. Okay. Let me draw a diagram here. So this is for 5 marks. So let me draw a diagram here. Or circuit of Wheatstone bridge. Now, Okay. This is a galvanometer. So this is a diagrammatic representation of the Wheatstone bridge. Now, let me tell you the construction here. So it consists of the four resistances, four resistors, that is P, Q, R and S. Is it or not? So these are arranged in the form of a bridge. So these are arranged in the form of a bridge. So a source EMF, that is E. This is E. A source EMF is connected between the points A and C. Is it or not? These are the EMF is connected between the points A and C. So a galvanometer is connected between the point B and D. See, you can see here the EMF is connected between the points A and C, whereas galvanometer is connected between the points B and D. So unknown resistors can be any of the four arms of the bridge, that is PQRS. Usually unknown resistors is put in place of the S. Okay. So unknown resistor, this is kind of, let me consider this is a unknown resistors. Unknown resistor. Okay. Out of the four resistors, one is unknown here. Okay. One is variable and other two can be standard resistors. Okay. See, let me discuss the construction here. It consists of the four resistors, that is PQRS. Okay, these are arranged in the form of a bridge. So a source of EMF E is connected between the points A and C, whereas a galvanometer is connected between the points B and D. Okay, so unknown resistor in any of the four arms of the bridge. Let us consider S is in the place of unknown resistors. Let us consider S as a unknown resistors. Okay, so the statement for now, what is Wheatstone bridge here? See, Wheatstone bridge. Please note down it. Wheatstone bridge. Okay. Wheatstone bridge is an arrangement of arrangement of four resistors in the form of a bridge. Is it or not? In the form of a bridge, it is used for measuring the, for what it is used? It is used for measuring the measuring the unknown resistor. Is it or not? Unknown resistor in terms of remaining three no resistors. See, Wheatstone bridge is an arrangement of four resistors in the form of a bridge. It is used for measuring the unknown resistor in terms of the three known resistors. So this is the concept here. This is the concept here. Now, what is the principle here? Principle, that is P by Q is equal to R by S. We need to derive this. Okay. We need to derive this. See, let us look at the diagram here. Okay. See, when key, this is the key here. Sorry, I have not noticed. See, this is the key here. This is the key. K. Okay. So when this key is closed, when this key is K is closed, the galvanometer shows the presence of current, that is Ig. Here mentioned Ig through it. The value of the resistance, say R is adjusted. See, R is adjusted in such a way that galvanometer shows no deflection. See, when the current will flow here, when the key is closed, the galvanometer shows the presence of current, that is Ig. But the value of resistance, say that is R, in the resistance of value of the R is adjusted in such a way that galvanometer shows no deflection. Even though the flow of current will takes place, the galvanometer should not deflect here. Okay. See, when the key is closed, the galvanometer shows the current, presence of current, but this galvanometer should not show the deflection. So in such a way, the resistance R is designed, okay, or connected. So at this stage, the potential at a point B, where is B here? Here, B. Okay, at this stage, the potential at point B and D is equal, hence no current flows through the galvanometer. Why? Because no deflection, because at this stage, the potential, whatever the potential applied at the points B and D is equal, so the no current flows through the galvanometer. So Wheatstone bridge at this stage is said to be balanced. Okay, at this stage is to be balanced. Now, so the Wheatstone bridge at this stage is said to be balanced, and the ratio of P and Q is equal to the, that is P by Q is equal to R by S. So let me explain you in one or the other case. See, when the key is closed, okay, the galvanometer shows the flow of current, that is shown as in the figure, that is Ig. But galvanometer should not, will not show any deflection, because whatever the current flowing in between the points B and D are equal. So no current will flow through the galvanometer. So the Wheatstone bridge is at this stage is said to be balanced. This is said to be balanced. The ratio of P by Q is equal to the ratio of R by S, as I have mentioned in this So now proof. Let me prove this. Okay. Now when key K is closed, the current flowing in the different arms of a Wheatstone bridge are marked according to the Kirchhoff's first law. What is Kirchhoff's first law? So let us consider a one loop here. So that is so let us consider one loop, that is ABDA. Okay, this side of the loop. So according to the Kirchhoff's loop law, that is also current law, we get according to, so let us consider the loop, that is ABDA in the figure. See, you must have to see the diagram here, otherwise you will not get it. So what is the loop law according to the Kirchhoff's? Now according to Kirchhoff's loop law first law first law, what is first law here? The algebraic sum of all the currents. That is, see, if you see the diagram here, I2, let me show you. See, if you see the diagram, sorry, this will be in this direction, I1. This will be in this direction. Now, according to Kirchhoff's laws, look at the diagram. It is equal to the ABDA. If you consider ABDA, this is opposite to the direction of the current. So therefore, I will write this as minus I2 into P. Is it or not? So I mean, according to the flow of current. So in the same way, I will take minus negative I2 into P minus the flow of the direction of flow of current is also in the same direction. I will also take Ig as including the galvanometer current, that is minus Ig into capital G. So if you consider opposite to the flow of current, that is the direction of I1 into R at the resistor R is equal to 0. Okay, let me write in the that page. See, according to Kirchhoff's loop law, ABDA, look at the diagram. See, I2, Ig are in the direction of flow of current. So, if any direction of flow of current will takes place, then the current will also be written as negative direction. So it is having the resistance P minus the Ig current is also in the direction of flow of current. So therefore I will write Ig into G plus but this resistance R having the opposite to the flow of electricity. That's why I will write I1 into R. Is it or not? The resistance R here. So that is equal to 0. This is equation number 1. Is it or not? Okay. Now applying in the same way, applying Kirchhoff's loop law to the closed loop, that is BCDA. So suppose if you apply the Kirchhoff's loop law or that same current law to the loop, that is BCDA. So let us consider BCDA. Suppose if you consider, look at the diagram. Look at the diagram there. See, BCDA, BCDA. Okay. So what will happen? Let us see here. See, this is I2 minus Ig. It will become I2 minus Ig. Why? Because the current flow from IT to Ig. So that's why I will write I2 minus Ig. Is it or not? Now, this S is having I1 plus Ig. I1 plus Ig. Okay. Now, according to the Kirchhoff's loop law, I will write, see, this direction is according to the flow of current electricity. Is it or not? So that's why I will write negative I2 minus Ig. What is the resistance there? Q. Is it or not? Now, but the direction of flow of current in case of resistance unknown resistor, that is S, is equal to the opposite to the direction of electric current. That's why I will write positive sign here. So that will become I1 plus Ig. Please note on it, I1 plus Ig, that is, and remaining current, that is opposite to the flow of electricity, that is Ig into G. If you consider in the case of galvanometer. Okay. Now see, BCDA. If we apply the Kirchhoff's loop law here, that it will become minus I2 into Ig in the resistance Q plus I1 plus Ig. In the same way, in the galvanometer current, that is, this is in case of S. Case of S, and it will become Ig into G. This is equal to 0. So this is equation number 2. Okay. So in case of balanced Wheatstone bridge, then there will be no current will flow. In case of balanced Wheatstone bridge, no current will flow in that case through the galvanometer. Therefore, Ig will become 0. So apply this Ig is equal to 0 in case of equation number 1 as well as in case of equation number 2. What will happen? Let's move. Suppose, see, equation number 1 will become I2 into P plus IR is equal to 0, or we can also write it as I1 into R is equal to I2 into P. Is it or not? This is I1. I1 into R is equal to I2 into P. So let us consider this is as equation number 3. So if you apply the Ig is equal to 0 in equation number 2, it will become minus I2 into Q plus I1 into S is equal to 0, or we can also write it as I1 into S is equal to I2 into Q. This is equation number 4. Okay, this is equation number 4. Now divide. Now divide equation number 3 by 4. What will you get here? That is I1 divided by R into divided by I1 into S is equal to I2 into P divided by I2 into Q. So here I1 get cancelled, here I2 get cancelled. We will get P by Q is equal to R by S. This is the equation for Wheatstone bridge. Okay, this is all about the Wheatstone bridge. So let me explain you once here. See, this is the diagram. This is the diagram for Wheatstone bridge. See here, the 4 resistors at the point A, B, C, D, P, Q, R, S resistors are connected at the point A, B, C, D, where EMF is connected in between the point A and C, and the galvanometer is connected between the point B and D. There also a key is connected. So I1, I2, I3, I1, I2, and suppose if you consider I2 minus Ig is a this direction, and I1 plus Ig in this direction. So suppose uh, so this is a construction part. So what is Wheatstone bridge? See, Wheatstone bridge is an arrangement of 4 resistors in the form of a bridge. It is used for measuring the unknown resistors in terms of the 3 known resistors. Here, there we have considered unknown resistor as S. So what is the principle here? We need to prove P by Q is equal to R by S. So S is the unknown resistors. So let us consider the loop, that is ABDA in the Look at the diagram there. So according to Kirchhoff's loop law, we will write ABDA as minus I2 into P minus Ig into G plus I1 into R is equal to 0. This is equation number 1. And BCDA, it is equal to minus I2 minus Ig into Q resistance and I1 plus Ig into S in S resistance and Ig into G. This is equation number 0. Suppose the Wheatstone bridge is balanced. I have told when it is balanced, the net current flows through the galvanometer in between the B and D is equal. Therefore, the current Ig will become 0. So suppose if you substitute Ig is equal to 0 in equation number 1 as well as in equation number 2, you will get this equation, that is I1 into R1 I1 into R is equal to I2 into P. Suppose if you consider Ig is equal to 0 in case of equation number 2, you will get I1 into S is equal to I2 into Q. This is equation number 4. Now divide equation number 3 by 4, we will get P by Q is equal to R by S. This is the expression for Wheatstone bridge. This is the final expression for Wheatstone bridge. Hence the proof. See, if Wheatstone bridge cell and galvanometer arms are interchangeable, okay, these are, you can interchange this, okay, we can interchange the cell galvanometer, okay, cell and galvanometer arms. So if bridge is not balanced, the current will flow from D to B, okay, where I have told you the current will flow from B to D. Okay, so if a bridge is not balanced, the current is not equal to 0. Where the current flow of current in between the P and D are not equal, the bridge is not balanced. Okay, in that case, current will flow from D to B. Okay, this is all about the Wheatstone bridge. We have proved here. This is all about the Wheatstone bridge. So dear students, this is the completion of your third chapter, that is current electricity. So I have discussed everything in this chapter. Please note the important points and notes. So make a short notes here there because it will help you in the examination part of time. So you can note down the PDF whatever I have shown on the screen. So this will help you in the examination part of time. Okay, this is all about the syllabus whatever I have taught in this class. This is all about the third chapter of your syllabus, that is current electricity. So by this I'm going to wind up the session in today itself of the third chapter. This is the completion of your third chapter, that is current electricity. So dear students, please listen to the previous classes and then apply your knowledge to the upcoming classes also, because it will help you. And please note the whatever I have taught in the class, and please revise once or twice, and then only you will get the clear concept about this chapters. Okay, so do practice and have a proper timetable and start preparing for your examination. So thank you.